So, oh, well, might be handy like this. Hi, I'm Klemen. So a couple of months ago at a hackathon, we sort of saw a couple of very nice speech-to-speech demos and figured we'd try and build our own. And after, let's say, 2 to 3 hours of work, we had something nice and functional. And then we're like, okay, let's see where this goes. And of course, what you build at a hackathon tends to be very simplistic and not ready for an actual application. So this is sort of the journey along the way of building a speech-to-speech application using Django. So without further ado, well, let's let the bot do the talking. We've got, this is the hackathon slide. Here we have what has been built. I'm going to have to, oh, actually, I think this is extremely awkward. So we started, this was the V1, everything's good. Oh. The V1, everything's sort of functioning. But you'll see.
Wat is uw voornaam en achternaam?
Friso Kolkman.
Wat is uw geboortedatum?
1 januari 1990.
And so on and so on. You get the idea. So this was all well and good for a hackathon. We figured out basically you could put a little beep in there to fool people into thinking that it's actually responding a little bit faster than it is. But if you want to actually make a phone conversation out of this, which was the end goal of this, this is painful. This is, I mean, if somebody spoke to you on the phone like this, I think you would hang up after about 30 seconds. And nobody would blame you. So, there we go. Where did the time go here? So, our 12-second, that initial, I think it felt a lot longer than it was, but that initial thing was a 12-second break between somebody responding and the bot actually going on to the next question. That 12 seconds breaks down into transcription, answer validation, which of course you want to do because you want to guide this conversation in some way. If you keep it open-ended, it becomes a little bit less useful, I think. And of course, then the last bit, which is speech generation. So, given that we started off doing this in a sort of sequential manner, the first bit was essentially changing the architecture of the system, and I'll take you through that firstly, and then through two sort of interesting problems that arise from both validation with LLMs and with just general problems around using them in a production sort of environment. So let's start with a very simple diagram here. These are all the components that we built for this, well, okay, initially everything was being done in sequence, so you might want to instead stream parts of this, i.e. make it an event loop. So there's that central bit, the data flow manager. I'm sorry, I can't see this on my screen here because it's a bit small. This connects, of course, to all the other components and sort of dispatches messages. The audio orchestrator connects this to a phone system, so you can actually call this. The audio consumer, this is our transcription service. You use external services for this generally. You can also run stuff locally. The dialogue manager, this is the interesting one. This is where the LLM sits. It tries to guide the conversation and make sure that you stay on track. You're trying to answer the questions that it's posing you. And then you have the audio producer, which sort of generates the audio. This it responds in speech as well. I'll take you really quickly on the path that a piece of speech takes through the system. So you have somebody speaks, a user speaks. This gets passed to our transcription service, which then notifies our main point of contact that there is text available. We then pass this on to our LLM in order to validate the answer, to make sure that the user isn't speaking some kind of gibberish, which then passes it on to, assuming that it's not gibberish, passes it on to our audio producer to generate some audio and make a response, which is then given back to the user. Now, for the sake of convenience, we built this out to use essentially external services, so that, well, this is essentially just a bit of glue. So here you have a big list, and I'm sure you're familiar at the very least with GPT-4 at the back over there. And some of you might have probably heard of Whisper if you use any kind of voice applications. Deepgram as well is another transcription service. The reason that they're redundant here is because one of them can detect when your speech ends and Whisper can't. It can't stream, you can't stream audio into it, and you can't detect when a user stops speaking. You just have to put second cutoffs, which is a bit inconvenient. We use Elevenlabs for voice generation, so yeah. And of course, Vonage here to connect it to a phone service, which I guess we'll get to see a bit later. So, back to our initial problem. Why does our caller here take 12 seconds to find out that actually you can't come to a conference as a pigeon? You have to be either a participant or a speaker, or rather an attendee or a speaker. We've dealt with the sort of initial problems, but now let's look specifically at validation, because it's sort of at the core of how you would guide a conversation with a user. So, this seems like the perfect use for the function calling or tool use that language models provide, nowadays at the very least. So you say, okay, given this bunch of speech that I've got, is the user talking complete nonsense? And if they are not, give me back an answer as well as saying, okay, this is valid. You'll see in this bit of code here, I think we've kind of pirated this out of LangChain, using Pydantic to make these function calls much more readable. Because if you do this as a standard sort of JSON layout, you look at this in your code and you're not going to have a very nice time reading it, I think. So, here we see a couple of different types of responses that you can get from an LLM on our pigeon example. At the top, we've got what the function call that I showed you earlier will produce. So a full reason as to why it's not valid, the validity assessment, and then of course the extracted answer. We can remove the answer bit if we want this to go a little bit faster. We can also remove the reasoning if we want this to be a bit faster. But of course, if you've seen sort of studies with LLMs where if you're using an LLM as a reasoning engine, you essentially assume that the more tokens it generates, the better it is going to be at some kind of reasoning task. Because it's like you counting on your fingers. You can more easily keep track of where your count is, for example. Same thing with LLMs and the number of tokens that they output. So why would you then choose to output a single token? Well, does that work even? Rather surprisingly, outputting a single token is just enough, because at this point, if you have a guided conversation where you know the next step, you just need a gate. You just need to have something say, give it a sanity check, and say yes or no. For extraction, that won't do, but given that we've just changed everything to be asynchronous, you can do this in the background. But what about accuracy? Again, we've said that reasoning takes a good couple of number of tokens to do well. So does that suffer as well? Well, also rather surprisingly, not quite as much as you would think. The single token sort of reasoning performance is within about 5% of your full reasoning in either direction. So if something has failed to pass this initial gate, in 5% of the cases, the follow-up will say, okay, this was actually true, but we've asked the user the question again anyways. And in the other case where it doesn't pass, or rather it does pass the gate, the follow-up validation is going to say, okay, sorry, this was actually complete gibberish. I don't know why we're continuing the conversation. The benefit here as well is you can use various prompting techniques. So few-shot prompting would be a very good example. Put a couple of examples of your past use cases or edge cases into the prompt to improve it. To say, okay, this is an example you failed on before. This is what it should have been. With a big red asterisk over there. And I'd make that a little bit bigger and a little bit redder if I could, because with transcription, you get some very, very interesting results. So, can anybody figure out what's going on here? Yes. We're trying to validate a postcode, which probably as our previous speaker mentioned, you probably shouldn't do. There's better ways to do that than with an LLM, but we tried it anyways, and we got this result. So, if anybody guessed one additional space somewhere in the middle inserted by our transcription model, you would be correct. Watch out for those. Yeah. So this isn't sort of the only odd thing you encounter when you look at transcription models. Sometimes you'll see that when the room is silent, when there's nothing going on, they'll just start transcribing random stuff out of their training data. So here's a very good question that some of you might have come across on the internet, which is why is it telling me that actually I should subscribe to someone's YouTube channel when in fact there's nothing going on? We found in the sort of Dutch versions, if your silence sounds particularly Dutch, you might find that your silence sounds very much like TV Gelderland. So, I guess in this case, you can also see why you would want to use an LLM for validation, because this is a complete non sequitur. So you can ignore this with an extra sentence, just say if something just completely doesn't make sense, ignore it, move on. So, having sort of solved these problems, and of course the postcode thing we've now done as a regular expression because it's a bit silly to, it's like pointing a cannon at a fly and saying, okay, let's, you should be valid. After solving these problems, ooh, these are the words I don't like to hear. Live demo. I think a bit like your average 2014 Volkswagen. The second these words get spoken, your code starts acting a bit differently. So let's see if I have, where is, I should have, is there a Firefox thing up there somewhere? Yes, okay. I can't see it on this screen, unfortunately. Ooh. Hold on. We will be, right. Open the correct tab this time around. So, here we have our little conference questionnaire, which I'll let you try out in a second. If I find my mouse. Okay. we did establish that things tend to start going wrong the second the word demo shows up. Where? Oh. All right. Oh, that's not meant to, well. Has it shut down? It has shut down, hasn't it? Oh, it's all disappeared. Okay, well, in that case, we'll make this worse. And instead of a live demo, we'll do a hands-on one. And you'll see there a phone number, which you can give a call. And as long as you're not all too loud all at once, you might be able to experience you might be able to get the sort of conference questionnaire experience. But yeah, if you want to take a picture of this, and then we'll take questions. So yeah. Yeah. I think the more of you try this out at once, the nicer it's going to be, because I get to see if I set something up wrong in the background.
Maybe you can call it yourself and then let us hear what you're talking about.
Actually, that's a solid idea. Is that the right number? Yeah, I've called this one before. I just need to make sure that I'm not accidentally calling my dad. This isn't trivia. I don't get the 50-50. So.
Thanks for calling and taking a moment to give your thoughts on the conference. Were you an attendee or a speaker?
I was a speaker.
Which of the talks you attended did you find most engaging?
Oh, I think the one about when to use an LLM. He was quite a fun guy.
Sorry, that's not on the list. Try again.
What do you mean it's not on the list? He's the previous guy. When to use an LLM.
How would you rate your conference experience on a scale from 1 to 10?
I'll give it a 7. The demos could have worked a bit better.
Thank you, and we hope to see you back next year.
All right.